Okay, so applications, right? If money is invested at 3% compounded differently, calculate the amount after 5 years if you start with $2,000, right? So we have an annual, compounded annual situation, compounded monthly, compounded daily, and then compounded continuously. And I know I talked to you about this, but in all cases, right, the rate is 3%. So that your R value in every situation here is going to be R equals 0.03. Your principal is $2,000. And your time is, what's the time here? 5 years, right? So we're basically going to use these values. Now, the only difference is for the monthly and the daily situations. I guess you could group the annual in there too. There's a frequency where it's being compounded, right? Intervals. So annual, that's that N would be 1. Monthly, N is 12. It's going to be compounded 12 times in 1 year. Daily, N would be 365. And continuously, right, is we're working with this function. P times e to the RT power. For the others, we're going to work under this scenario, right? So your output is going to equal principal times 1 plus R over N to the NT power here, right? So it is a formula. You're going to use this formula for the first 3, and then you're going to use the P times e to the RT formula for that last one there. So let's take a look at what happens here. Where's my pen? Okay, so get this piece out of the way. So in the first one there, we can see that it's we're starting with our $2,000. Is it 2,000? Yeah. So we're starting with a 2001 plus the rate over 1 because it's only happening 1 time a year, raised to the 1 times 5 power. Second one, same formula, but we're just replacing N with 12 here. Third one for daily, we're replacing N with 365, and you can see the values are increasing, right? So the more it's compounded a year, the more money you're going to grow, right? It's going to grow faster over time, right? So you can see it's 2,318, then it's 2,320, and then it's 2,320, but it's 65 cents versus 23 cents. And then the last one for compounded continuous interest, it's 2,323 and 67 cents. So it's 2 cents more than the daily model, but it's still more, right? So compounded continuous is it's going to grow the most over time there. Okay, so you can try this one, right? 6% compounded differently, 4 years, right? And we're starting with $4,800. So you can go ahead and calculate these. I'll pause it and show you the answers in a minute. So here are the values for the 4 different scenarios. And again, you can see the annual value is 6,059, then it's 6,098, then it's 6,101.90. And then it's 6,101.99, I think it's 5, so I just rounded up to 6,102. Again, formula based, it's pretty basic. Once you do it a few times, it doesn't really change very often.